Okay, let's use what we know about proportional relationships to solve some application type problems. A scale drawing represents an object as smaller than or larger than its actual size. You've probably seen a lot of different scale drawings. Looking at a map, they have a scale on a map. The drawing scale is the ratio of any length in the drawing to the corresponding actual length. So the scale is a ratio. All right, so let's look at a problem. On a Wisconsin road map, Kristen measured a distance of 11.25 inches from Madison to Wausau. The scale of this map is 1 inch to 13 miles. That means that if you measure 1 inch on the map, that represents actually 13 miles on a road if you're driving. What is the actual distance between Madison and Wausau to the nearest mile? All right, so let's start off with the scale that they give us, 1 inch, and I highly recommend putting the units on this because it helps you keep track of things should be on the top or on the bottom. 1 inch to 13 miles equals, now what's the other number that they give us? 11.25 inches. Now, you could also write here, map, and then the real world, or the road. So the 11.25 inches, what does that represent? Is that a measurement on the map, or is that a real distance? Well, obviously that's the measure on the map, so that's going to go on the top, so it matches up with 1 inch in the other fraction. So 11.25 inches. And then the actual distance, I don't know, call it D, and then I'm going to write down here, just to remind me that my answer D is going to be in miles. And now we just treat it like every other proportion. We cross multiply and solve for the missing variable. So we have 1 times D equals 13 times 11.25. And grab a calculator if you like. 13 times 11.25. And you get 146.25. 46.25 miles. And then you reread the question, what's the actual distance between Madison and Wausau to the nearest mile? So that means that our answer is going to be 146 miles. And that's it. Pretty straightforward. Let's look at another example. Tyler wants to find the height of a telephone pole. The sun is out and he measured the pole's shadow and his own shadow, and then he made a diagram. What's the height h of the pole? So we have two similar triangles because we can assume that the angle that the sun makes is going to be the same for both of those, and that Tyler's standing straight up and the pole was put in properly. So by angle similarity, these two triangles are similar. So let's set up a proportion. Now, as we've talked about, there's a lot of different ways we can match this up. We could say Tyler's height to the pole's height equals Tyler's shadow to the pole's shadow. Or we could do Tyler's height to his shadow equals the height of the pole to its shadow. Or we could reverse it, the height of the pole to Tyler, the pole's shadow to his shadow, etc. So there's a lot of different ways that we can set up a proportion. But that's not going to be the tricky part here. So I'm going to go 5 feet 9 inches over h should match up with 7 feet 8 inches over 38 feet 4 inches. Now, normally you cross multiply, solve for h, we're done. Except here our units are mixed. We have feet and we have inches. So we have to make a decision. Do we want to stick and write everything in terms of just feet, or do we want to convert everything to inches? Let's look at it both ways. If I want to convert to feet, then that 5 feet 9 inches means that I'm going to have 5 point something. Well, what's 9 inches? There's 12 inches in a foot. So 9 inches is 9/12 of a foot. What's 9/12? If you divide it on a calculator or if you reduce it, you'll see that it's 0.75. So 5 feet 9 inches is 5.75 feet. All right, so let's do that conversion for each of these, and we'll have everything in terms of feet. So we have 5.75 feet over h equals 7 feet 8 inches, so what's 8 divided by 12? Well, that's 2/3. That's actually 0.6 repeating. And so now here we run into a little bit of a problem, because if we round our answer, then we may be off a little bit in our final answer. So I'm just going to leave it at 7.6 repeating for now. And then 38 feet 4 inches, well, that's going to be 38 point, and 4 inches, 4/12 is 1/3. That's 0.3 repeating. All right, so that's one option for solving. And let's see, and this is all in feet. So our answer h will be in feet as well. So we cross multiply, and we're going to get 7.6 repeating times h equals 5.75 times 38.3 repeating. And then we grab a calculator and try and punch those in. And how's that going to work? Well, 5.75, that's easy enough, times, now 38.3, I guess I could just put 38 point and a whole bunch of threes, or maybe I could do 38 plus 4/12. That's the same as 38.3 repeating. And then I'm going to divide all that by 7.6 repeating. And so how do I enter 7.6? Well, how about if I just do 7 plus 8/12? And so we get a final answer of 28.75, and we know that that's in feet. So 28.75 feet. So that's one possibility. Let me write that over here. Now, what if you wanted to convert that to feet and inches, like the original problem? We need to know what's 0.75 of a foot. Well, a foot is 12 inches. So what's 0.75 of 12? Well, we already had that decimal. That's 9 inches. So another answer we could say is 28 feet, 9 inches. The other option would be if we converted everything to inches instead of dealing with the feet and the decimals. So let's go back 5 feet 9 inches. I'm going to have to convert the 5 feet. Well, there's 12 inches in a foot, so 5 feet would be 12 times 5, that's 60, plus the 9 inches that we had already. So that's going to be a total of 69 inches over h. And then the other fraction, what's 7 feet 8 inches? Well, that's 7 times 12, and then plus the 8 inches. So that's 92 inches. And let's put that here. And then 38 feet. Well, what's 38 times 12? That's a big number. And then we'll add 4 to that. It's 380 plus another 76. So that's 456, so I think that should be 460. Maybe I should grab a calculator. I'm pretty sure that's right. And then you cross multiply and solve that one, and I won't bore you with the details. But you should wind up getting 345. And remember, that's in inches, because everything's in inches there. So we generally would never see an answer like that, 345 inches. So the 28 feet 9 inches or 28.75 feet, those would be better answers for this problem. But the big idea is that you have to make sure that you have the same units throughout. All right, let's look at another one. The Statue of Liberty holds a tablet in her left hand. The tablet is actually 7.19 meters long by 4.14 meters wide. Let me draw that. So let's say this is, that's not the best rectangle in the world. Let's say this is the actual tablet. Let's make that better. There we go. 7.19 meters by 4.14 meters. Remember, a meter is a little more than 3 feet, so that's pretty big. You want to make a scale drawing of that tablet. And you want the scale to be 1 centimeter on your drawing equals 0.75 meters of the real tablet. What should be the dimensions to the nearest tenth? Okay, so now you want to make a drawing on a piece of paper in centimeters. So let's call this L for length and W for width. And let's set up a proportion. So we're actually going to have to do 2 proportions. First, let's solve for one of these. Let's solve for W. So I want W, and that matches up with what? 4.14, and that's meters, and my W is going to be in centimeters. And so that equals, what's our scale? 1 centimeter, so that's going to be on the top of our fraction, because we have centimeters on top in the other fraction, and 0.75 meters on the bottom. Okay, so just a couple of things to point out here. I decided, and I could have set this up, I could have done 4.14 to W if I wanted. But what you have to look at is the units. My W, my drawing is going to be in centimeters. And then the actual is in meters. So when I do my scale, make sure that my centimeters are in the same spot and that my meters are in the same spot. And then we'll be good to go. Before I solve that, let's go ahead and do the same for L. So L over 7.19, and that's meters. L will be centimeters. Will also equal 1 centimeter to 0.75 meters. So we cross multiply, we're going to get 0.75 times W equals 1 times 4.14. So we're going to divide 4.14 by 0.75. And let's grab a calculator. And 4.14 divided by 0.75. And we get 5.52. And let's go back here. And remember, it said round to the nearest tenth. So that's going to be 5.5 centimeters for the width of my drawing. And then for L, I've got 0.75 L equals 1 times 7.19. So once again, let's do 7.119 divided by 0.75. And we get 9.586. I'll just write 9.58. And that'll round up to 9.6 for my L. And that's centimeters as well. And so there's the dimensions of my scale drawing. As long as you keep track of the units, you shouldn't have any problem, however you decide to set up your proportion. All right, one last idea, which is kind of important. And it says if the similarity ratio of 2 figures, okay, is A to B, so the ratio is A to B, then the ratio of the perimeters will also be A to B, and the ratio of the areas, that's in a different color, is A squared to B squared. Let me give you an example so you understand what that means. So here we have 2 triangles that are similar. LMN is similar to triangle QRS. Find the perimeter and area of QRS. So notice in the bigger triangle, we have one of the sides, 13 centimeters, and that matches up with this side, RQ, which is 9.1 centimeters. We know the perimeter and the area of this triangle. We want to find perimeter and area of this one. Let's start with the perimeter. I know the ratio of the perimeters is the ratio of any 2 matching sides. So that's how I set up my proportion. So I'll say the ratio of the perimeters, so 36, and this perimeter we'll just call P, over P equals 13 over 9.1. So this perimeter to this perimeter equals this side to this side. That's what this theorem is telling us. And that's it. So as long as I give you two matching sides, you take that ratio and set it equal to the ratio of the perimeters. So let's cross multiply, and we get 13, whoops. I'm just going to do it in one step. We'll get 13p equals 36 times 9.1. And then we'll divide both sides by 13 to get p by itself. And let's see what we get. 36 times 9.1 divided by 13. 25.2 is the perimeter of the other triangle. Now the units on these were centimeters, so the perimeter will also be in centimeters. Okay, now let's do area. So the area of the smaller one, actually, it doesn't matter the order you do it, I'll stay consistent so I don't confuse you. So the area of this triangle is 60, we don't know the area of this one. So I'm going to say 60 over A equals 13 squared over 9.1 squared. And that's what this theorem told us. The ratio of the areas is the square of the ratio of the sides. So it's not just 13 over 9.1, it's 13 squared over 9.1 squared. So 60 over the area of the smaller one equals 13 squared over 9.1 squared. So when I cross multiply, I'm going to have 13 squared times A equals 60 times 9.1 squared. And then I'll divide both sides by 13 squared, and I'll have A. So now we grab the calculator, slide it over here, type it in as is, 60 times 9.1 squared divided by 13 squared. Notice I waited till the end to do any calculations. I'm not calculating things as I work through it. And we get 29.4. So the area is 29.4. And now the units here, well, this is the clue. You know that it's going to be units squared, and everything's in centimeters, so we're going to get centimeters squared. And that's it. So the ratio of the perimeters equals the ratio of any two matching sides, but the ratio of the areas is the square of the ratio of any two sides.